Hello. Our guest today is Yuri Balasanov. Yuri teaches advanced analytic courses at the University of Chicago, and he also runs a consulting company focusing on applying artificial intelligence for optimizing business decisions. And Yuri, we spoke last time about 2 years ago, and we spoke about increasing role of analytics caused by wide acceptance of big data. 2 years. We also discussed challenges and new approach in teaching of new generation of students and data scientists. 2 years. What are the most significant changes happened with application of advanced analytics since our first interview?
Thank you, Boris. That's good to be with you again. 2 years, but it feels like yesterday.
Right. On one hand. On the other hand, a lot of things change.
The world has changed.
Yes.
And it's interesting that you're asking this question, because when I think about it, it is true, it feels like the whole world changed. But what exactly, everything that we need to talk about now, if we're talking about changes, has existed already and had existed 2 years ago. TensorFlow, the main methods,
Deep learning.
deep learning existed, driverless cars existed, computers started playing games better than a human. Chess champion had already been beaten.
Kasparov was beaten.
Yes. So what indeed has changed? Even though everything had existed 2 years ago, probably not everything checked with us. So our feeling about this.
What do you mean?
Some things that change now don't seem important yet.
Okay.
Until it hits.
Okay.
So probably what happened during this period of 2 years is just realization that what we knew about did not seem important, but now it is.
Okay.
And this is a very significant change, because even though the world is changing continuously, it's changing so fast that it seems like it's been a jump.
Yeah.
It seems like it's completely turned into something different.
Yeah, artificial intelligence is not new discipline, but applications is fantastic and unbelievable.
And the level at which it works
Right.
has changed. And you asked about my teaching students. That has changed too. I had to develop a new generation of courses that I couldn't teach back then because the subject did not exist.
Okay. But 2 years, in 2 years, which analytic methods found the most significant progress from your point of view?
I think we have experienced unification of all methods in the framework of neural networks.
Okay.
Deep neural networks.
Okay.
You take any model going back to even Gauss time, and everything can be implemented now in a few minutes
Using different methods.
By just using neural network. You select enough depth, and everything will be done. You don't have to go to specific methods, specific packages. Everything is done from the one unified platform and unified way.
Can you give examples?
For example, when you see an autonomous car driving in the street, that car has a neural network inside. There is a neural network that does vision. There is a neural network that makes decisions.
Okay.
If you see a robot working in the factory or walking at home, if you watch Boston Dynamics robots, inside there are neural networks. And neural networks just replace all models that need to be used.
So can you go a little bit deeper and talk about progress with application of analytics and artificial intelligence in robotics? I know this is something hot topic for you right now.
Yes, I've been very interested in this topic. I've been working on application when working with students, studying it for about a year and a half now.
Okay.
And I recently started first robotics club at the University of Chicago with students. And I see this enormous amount of enthusiasm that a generation of the students have and show when you talk about robotics. We just recently had a robotics show showing first quarter results. And it is just not possible not to notice how excited people are. And I must say that this is a generational thing that probably will be the signature of a generation. The robots that we're using now are sold as toys for 9-year-old kids. Right now. You don't have to have any background, any electrical engineering experience. If you put it together as a Lego, you just put few screws around, and this is a fully capable robot for doing something very intelligent.
This is mechanical part. What about artificial intelligence?
Inside there is a little card of a size of a soap box.
Okay.
And that soap box runs the most advanced artificial intelligence models, same neural networks. You don't have to put anything there. Everything is ready. Math is ready. The hardware is ready.
So
software is ready.
9-year-old kids use a robot and learning how to use artificial intelligence. Can they modify these programs?
Yes, you can write everything from scratch.
Okay.
And you can do serious things, very significant decisions that can be made on in real time.
How's popular your course at University of Chicago?
Very popular, and people come and it's not good, but they sometimes tell, I don't want to go to a different class, I want to spend time here. And this is important because we know from history, when every teenager, every young person wants to take electric guitar and play it, we know there will be Beatles, and we know the world change. If you listen your satellite radio, difference between 40s and 50s and 60s is different, it's huge, right? It's a different world. We also know, you and I, from Russian literature, the entire Russian literature is written by people of one generation. They all could be literally born by one mother. So that's when every person in that generation dreams about writing poem or writing some novel. Your Tolstoys and your Chekhovs come to place. I'm absolutely believer. Totally believe in few years these teenagers, these 10, 15-year-old kids, they will transform our world. And through them, with their help, robots will come into our life in every side of it. It will be the battlefield, it will be at home, it will be in the agricultural field, construction site, everything will be driven not by helpers, not by some machines helping humans, run by robots. And this is coming. We cannot stop that process, and everything is prepared for that. We have very powerful and very small size computers that can do the job. We have algorithms, we have software developed, we have generation that's ready to take it up on.
Hey Yuri, let's pick one example. Driverless cars. Okay.
Yes.
What kind of progress we see in applying artificial intelligence and different methods of artificial intelligence to make driverless car more effective, efficient? Any comments on that?
Sure. I must say that in autonomous cars today, the most impressive part is their vision. They do see around, they detect and recognize everything around, and they know how to use this information. And very complex visual hardware and software are used to do the job. The decision-making part is not that impressive, is not as impressive as vision.
What do you mean?
We
Decisions
see
regarding what?
we see this crashes, right?
Oh, yes.
We have seen videos, that infamous Uber crash, and I, of course, don't want to criticize people working on that. I know there's a lot of talent used there, and what I'm going to say is not against them. It's just my imagination, because I don't know facts. I don't know what's in that software. But with my limited experience with developing software and doing artificial intelligence, I imagine when I see those videos, when in few seconds the car did not even attempt to stop before hitting a human, and we know, unfortunately, there was first fatality. What I see and what I imagine is a lot of if-else statements.
Right.
If you see a pedestrian, then stop.
Rules-based.
Rules-based with if-else statements.
Right.
You can imagine in complex situations you have millions of if-else statements, and there is no way to put them together without any bug.
Right.
So that's the weakest part at this point. And it is inevitable. I must say that with the cars, with the real cars, with drivers, it was the same situation. First fatality by car happened in 1896. And the car was moving 8 miles per hour.
Yes.
And it hit a human, and unfortunately, that human died. And there were discussions whether cars should be allowed in the streets, because, as we know, horse would have stopped. We were passed through that. Just 20-25 years later, cars were mass-produced, and the horse industry disappeared all of a sudden. So we know it's coming. We know that cars are not, autonomous cars are not perfect yet. They will be much safer, by the way, if only autonomous cars drive the streets, not humans, because the most difficult part is understanding between human and computer.
You mentioned rule-based systems, a lot of
Yes.
what-ifs. And what is the trend?
The trend is we need to collect a lot more data capital. Tesla cars running around now, they are not just taking passengers from A to B, but they collect this enormously important experience, taping and collecting all information from sensors about everything that's going on around. That immediately gets used to train the algorithm of the next generation. So that's the process through which we need to go. And when we go through that, when we have enough cars running and collecting this information, training will go several levels higher, and we'll get much safer cars. I believe that.
It's still training.
It's still training.
What about situations when a human potentially can come out with something absolutely new, interesting decision, which we never experienced before? What is the future in terms of developing algorithms which can be innovative?
Yes, we hope there is something left to us that computers cannot do. And as a human, I hope so too.
But nevertheless.
Nevertheless, what we have to change is our understanding of what really is intellectual work. Driving cars requires some skills, but it's not intellectual. Not only humans can do that. Now we see that computers can do that.
Right.
Playing chess. Yes, computers can beat human now. Even more strategic game Go was a shock for many governments when in 2016, which was exactly just before we talked last time.
Yes.
In 2016, computer developed algorithm developed by DeepMind, now it's part of Google and Alphabet, defeated a world champion in the game that is considered much more strategic than chess. It was shock for many governments because they realized importance of that. They started putting money. Unfortunately, money first goes, of course.
So what kind of technology did they use to achieve this goal?
they use the algorithm pretty much the same as what I teach students now. And in 10 weeks, my students learn or teach artificial intelligence how to play games.
Okay.
We have, at the end of
I
my
understand
course, we have...
this part. What
Yeah.
I don't understand, how to come out with innovative algorithms, or algorithm which will model situations which we didn't experience before.
There are algorithms, so-called generative models.
Generative models. Okay.
Yes, that are used now in fashion design,
Okay.
used now in art, creative art,
Okay.
used in music composition.
Okay.
And if you look, let's for a second look not at how computer does it, but how in the current industry music is composed.
Right.
There is one person that takes little pieces, little suggestions, little ideas from many different composers working as a team, and that person's role is selection of the best of them and then putting together. So there's a lot of trials and errors, and only a small percentage of everything that was proposed is selected.
Okay.
Now you replace that big team with one computer that has a generative model running.
Right.
And some of those suggestions will be not good, but once in a while, computer can surprise you. And that already is happening. And in visual arts, there are galleries that now show art created by generative model. It's not copying, it's not reproducing something that some human already has created, but they really mix things in a way that sometimes surprise us.
Talking about computers, there's a trend right now, moving analytics to the cloud. Okay. What do you think about this?
I agree that there is such trend now. In the cloud, there is one important advantage. It democratizes the computer science systems. Anyone can log in and in a matter of minutes create and put together a system of any architecture you want. And the price becomes really affordable. So a lot of people have access to these enormous resources. And I think that is a very positive, because that's where fresh ideas will come and they will be implemented there. There is lots of arguments. In the University of Chicago, there is their own cluster of computer nodes, and they're considering providing students with some solution that is based on the cloud, where all software packages are pre-installed, and it's going to be called computer lab, artificial intelligence lab. Students will come and in minutes with their own data start solving problems. So definitely there is some consolidation of computer power going on,
Right.
and it allows us to use computer power in a much more flexible way.
Right. So, based on all of that, what is the long-term future of artificial intelligence and advanced analytics? When I talk about long-term, I mean 3-5 years.
Yeah, it actually doesn't have to be long-term, because I think that we will see changes much sooner than we think. Autonomous cars is a reality. We don't see a replacement of cars with drivers with autonomous cars yet now, but it is imminent. I think it will happen. There will be failures, but this world on the road will change significantly. Robots will enter our life in many different ways. And robots will be running, as I already said, on the agricultural field, on construction site. They will be following us and helping us to navigate on the street, especially people with disabilities. They will be attending us as nurse. It's hard to imagine what will not be affected by robots. We will have to learn how to live among them.
Yeah, phenomenal. Yuri, thank you very much.
Thank you, Boris.
Thank you.